Hello, welcome everybody. Welcome to this 60 minute of unscripted .net entertainment. No pressure.
Love it.
Our mission is to empower. I'm totally reading that part because I don't forget anything.
That part
The
is
rest of it
scripted.
okay, the intro is scripted. Our mission is to empower the .net community, so you people, to achieve more. I'm Frank, your host, and with me today I have Maria and David as my co-host, and I would like to welcome today's guest, newly MVP, Kristoffer. How are you, my friend?
Thanks. I'm doing good. Yeah. As I said, I just became MVP here in May, so that's pretty new for me and something I'm still figuring out how to use and get the best of.
So what do you want to talk today about?
So today I want to talk about Blazor.WebAudio, a Blazor wrapper for the Web Audio API. And basically that's something I've been working on over the last 1.5 years as a project, and it's going, like, obviously it's going slow, but it's something I'm having a lot of fun with and taking my time going in depth with, as you'll probably see today.
So that's a side open source project that you maintain.
Yeah, exactly. And I'm not done yet, but I'll probably soon be done. I have like a status chart of how many percent I'm done, and it's getting closer and closer to 100.
Awesome.
It's very exciting.
Yeah. Just to reiterate, as a daily basis, I work as a .NET developer at a company called Relevise. I just recently became a Microsoft MVP. I blog. Here is my URL for my blog, and then I'm active on GitHub and X and Mastodon. And I try to get on Blue Sky as well, but they don't allow me to upload videos. So obviously it's not really the material for example, content about Blazor.WebAudio.
I love the hesitance with saying X. Like that's amazing, because that's how I felt too with the whole thing. It's like, oh, this is Twitter, isn't it? Can we just call it Twitter still?
Yeah. I also, like, for the slides, I had first like a slide for the old Twitter logo. I had to find a new Twitter logo, X logo.
Oh, that's awesome.
Yes. And what we'll see today, first of all, we have to figure out what is this Web Audio API. Then we have to add a little demo of actually using the Blazor Web Audio wrapper for this API. Then I'll show a small keyboard that I made using the wrapper. Then we'll talk about error handling in Blazor.js interrupt using Blazor.WebIDL. And then, if we have time, some of the APIs that are related to it, which is the media capture and streams API, which I've also made a wrapper for that works pretty close with the Blazor Web Audio API as well. And then, of course, in the end, if there's any questions, or if there's any questions throughout the stream, just ask, and then we'll be happy to answer them, or like figure out why, or whether or not we can make some specific sound or something like that. Could be fun.
Awesome.
So yeah, first of all, the Web Audio API is an API that is node-based. So it is built around these different audio nodes that are connected together, and they can either work in the audio context or the offline audio context. So basically, the audio context is what we perceive live and basically outputs to your speaker, whereas the offline audio context enables us to render sound potentially faster than like normal processing, in order to maybe generate some sound file in the back end, while some other thing is happening in the front end. Yeah, and then as a part of these audio nodes, there are generally like 3 groups. Some are producers of sounds, some can process these in different ways, and some very simple ones are just for outputting in different ways as well. Yeah, and if we if we take like a quick look at this, obviously this is too much to go through, but I have like some different ones that can generally just generate sounds, like an oscillator making some oscillating sound, an audio buffer source node, something that takes the sound from some byte array basically and constructs a sound from that. Then there are some places that we can stream this to, and that is like the basic one is the audio destination node, which in the audio context would be just your speaker. So this is very much what we use the most of the time. And then there are a whole lot of processors which can manipulate and change the sound in a lot of different ways, like changing the gain of the sound, adding a small delay, panning the sound from left to the right of the speaker, a whole lot of different filters and processors. Yeah. And then there's even more because this graph is even stronger than just connecting different processors to outputs and so on. We can also use the producers as inputs for different params of the processors. So for example, a gain node has a parameter for the gain, which controls how high the volume is. And we can actually animate this using some other input from a producer or some other processor. So there's a lot of different ways you can set these processors and producers together, which can make some really interesting systems.
So we have some viewers. I selfishly asked the question about whether or not any of our viewers have used the Web Audio API, and admittedly, I have not myself. But people are saying no. A lot of them didn't realize that it even existed. So, out of curiosity, what's the can I use like bandwidth on this? Is it like above 90%? Like, is it supported in all major browsers, or where are we at in terms of supportability?
I think we're full. Like it's actually a very very old API, and we also see this in some parts of the API as in the earlier days we didn't use the async await model that much in JavaScript. So some of the methods still use like a callback for when some process was done. So that's like a legacy of that time. Whereas now they also have different overloads for just returning the results. So it has been around for a long time and is fully adopted by all the different standards, all the different browsers. Obviously, some of the browsers are more stringent on this. For example, Safari, they don't want you to play sound without the user having like actively pressed on some button or something similar. So
Sure. Okay, awesome.
So sometimes
I'm thinking I've only done boring systems that don't have audio. So it's like all like this very enterprise applications that don't use audio. So I think like a lot of people might be in that same category as well. Like it's like, oh, I didn't know it existed because like they've been doing very like enterprise database catalogs, that kind of thing, right?
But it can be fun for like introducing a little bit of sound, maybe if you press a button or something like that. Also, I think a lot of the origin of it is for like streaming, as we're doing right now, is happening over this API as well. So the API that is streaming data from the browser has to get it in some format, and that also uses the Web Audio API to actually fetch the data in the start, like as a takeoff.
Yeah, I just shared a link there for our viewers too. I did a quick search on the can I use for Web Audio API, and it is over 97% coverage. So that's awesome.
Yeah, I would imagine. Yeah, and then it's time for the first demo actually.
Woohoo!
Yeah.
Yeah.
Let's see if we can find out how to do this. Yeah, so while I'm preparing a new solution, you will find my repository here, which is where I'll do all the work. So if you want to follow what I do on a daily basis with the project, you can find it on GitHub. And there's even like a small demo if you see something throughout the stream that you want to try out yourself. There's like a small link to a demo here as well, where you can try things out. And I just have to remember how to do .NET new commands. Yeah.
If not, there's always the documentation that you can go
Yeah.
check it out.
Oh, great
True,
call
true.
out. Well played.
Yeah. Yeah.
I used to work on those. Like,
That was smooth.
Nice. Just to show that we are like on a whole new solution, and we were not like importing anything apart from the NuGet package itself. Yeah, so I just will find the NuGet package here.
Is that your
Also-
way? Is that your way, Kristoffer, of saying there's like no tricks up your sleeve? Like this is essentially just file new. Here's the project.
Yeah.
Here's the NuGet package. Let's go.
If the demo burns, this will be the reason. Yeah. And it's still an alpha. So in Visual Studio, you have to check this little mark that you will be able to search for pre-release packages as well.
mm-hmm.
And then we'll just install. And then while that's installing, I think it's already done. Amazing. We'll just go to the home page, and we will begin starting some sound. So my idea is basically we want to make the bare minimum, and that's just playing like a note for like half a second. So first of all, I want the button, and I'll say let's play some sound. Yes, and we have not hooked it up for anything yet, but we will do shortly. And then I need to inject the IJS runtime. And I prefer to call it the IJS runtime with a big J. I have to remember things. Yeah. And actually, before we get any further, it's nice to have it as a part of your imports so that you have it available anywhere in all of your pages. And just my name, and then Blazor, and then Web Audio as a start. And then we want to make some function that gets invoked when we have the button press. So that's just something we're going to call button pressed. And first of all, we need to create this context, which was the place where the sound was going to be exposed, in this case through our speakers. And that's the default one, which is called the audio context. So we say await using audio context equals to audio context dot create async. And there's a lot of constructors for this, as it's basically building on a hierarchy of different classes that are made throughout some different libraries. But the one we'll use is just the one that takes a JS runtime, which should return. Okay, is it the right one? Yeah, I think it's the right one. Why is it the it's helping me so much. Nice. Yeah, so that was the first part, and then we want to make some sound. So that was like previously we saw that whole list of different producers, and one of the simplest producers that we have is the oscillator node. So we'll await using the oscillator node. And the reason why I'm doing the await using is because these different classes, they are async disposable, as they are keeping the handle for the actual JS object underneath. So we are awaiting using it so that it automatically gets disposed once the method finishes, so that we don't keep this handle in memory for all eternity. That's like a common mistake for like making memory leaks when making JS interop.
That's a really good point to call out. And so I'm going to throw out a challenge question here for you, Kristoffer, Mr. Newly appointed MVP. Might you consider adding an analyzer that would help the consumers of this library when they use it incorrectly?
Yeah, I've seen those analyzers. I just haven't really found my way down to them yet. But it's a really good idea. But there are some different use cases that would make it difficult.
Sure.
Because sometimes you might want to assign the audio context to like a field.
Yep.
And in this case, we don't want to say that you have to await using it. But I guess some analyzer could figure out whether or not you are in the end disposing it.
Yeah, well, it could do it twofold. So if it's a class scoped variable, you could ensure that at least the class is, I think there might be disposable stuff that already exists for that. So you're covered there. I'm saying specifically in the context of a function like this, if it's intended to be scoped to that function and it instantiates it, you could write an analyzer that would hypothetically evaluate that and say, oh, hey, user, you might want to consider disposing of that in scope.
Yeah, that's an awesome idea. I think I'll make an issue for that afterwards, because I haven't tried to work with analyzers yet, and that's like a new opportunity to try out something new. So
awesome.
Let's do that at some point.
And just like that, Kristoffer, do you know what happened? You just learned that an open source project is never finished.
Especially when more people see it.
GA. You will get to V1.
Yeah, exactly.
And then you will continue to improve.
Adding more feature.
Yeah, exactly. I think like full coverage of the whole API first, then making the V1, and then seeing like what extra nice things we can do at some point. Probably the idea for me at least. But let's get back into it. So I was creating this oscillator node, and it has constructed a text JS runtime as well. But it also takes in the context of what world we are in right now, and then some different options for how we want to make some oscillating sound. And first of all, there is the type, and we want to make let's say we want to make a sine, because that's a nice sound to start off with. And then we have to choose some frequency that we want to play the sound at. And again, some nice sound is 440. That's like the sound that every instrument is like tuned to. So will probably sound okay.
And we can tell that you're experienced with this, because as you're coding this up, it's almost like you can hear the sounds in your head, and we're sitting here like, we don't know what the heck it's going to sound like.
Exactly. I have no idea.
Yeah, we'll see eventually. Yeah.
Oh, this is a good one. Cecil is here. Hi, Cecil. He's saying if David's going to create a DJ mixing board now in Blazor.
Oh,
funny.
Yeah, I would definitely use Kristoffer's library if I did. That's something that Brady and I have actually chatted about before. Brady Gaster, because he's into that sort of stuff, and there's definitely some cool opportunities. We should collaborate on something.
Yeah, that could be cool. Awesome. Yeah, and then the next part, when we're just making a sound, it's going to be like full volume as a default, and that can be a bit deafening, especially here on stream. So we'll use a gain node to ensure that we are not losing our hearing.
Thanks for that.
And yeah, no problem. And that again takes JS runtime, a context, and then some different options. And for this one, we want to set the gain to something pretty low. So let's say 0.1 floating point. And the last thing we're going to do is the actual destination, the actual place that we're going to send this to. This is called an audio destination node. We call this destination. And actually, that's like a helper method on the context itself that makes it really easy to get the audio destination. So we can just say context dot get audio or get destination async. Yeah. And
so
then,
does your wrapper like map one-to-one with all of the existing web audio APIs?
Yeah, it's one-to-one. So actually, it's not even me who came up with the idea of having like a helper. It's just like part of the API, as if you were going to use it in JS. But obviously it would be possible to like make some other different helpers if
Sure.
any of these things could be less verbose. And then we just need to connect all these things together. So we're going to say await the oscillator and connect it to the gain node. And then we're going to await the gain dot connect to the destination. But we are not finished yet because this oscillator node is actually a special kind of node. It's one of these producer nodes, which are also called audio scheduled source nodes. So this means that they are not going to play automatically just as you connect them. You actually have to start them. So we're just going to do that as well. Dot start async. Yeah.
So it seems like you have like truly finite control over almost every aspect of this audio API. That's incredible. It seems as though, I guess the only concern I have when I'm looking at this is that's a lot of code to play a single sound, but you have so much flexibility with it, right?
Yeah,
So
and obviously, if you have any of these parts that you're going to use a lot, for example, I'm often going to use an oscillator node in combination with a gain node in combination with the destination.
Yeah.
Then packaging that into some function that you can just call and get like an audio node as a total out would be a good idea.
Absolutely, I love that.
Yeah, and then we're actually just missing to hook up the on-click. So that's just it. And then we'll just start. And then we'll see whatever browser it will start in.
F5, and we cross our fingers.
Yeah. And it started in Edge. Let's see. Let's play some sound. And this is going to play forever, which is not good. So let's just fix that because obviously we want the sound to stop at some point. So actually there are some different options, as I said before, for these parameters of the different nodes, for example, the gain, that we can manipulate.
I'm glad you lowered the volume.
Yeah. I hope you are not deafened.
No. I mean, I just put the question out there. Did you all hear that? I heard it. So I think that's applause worthy.
Yeah.
I mean, think about it. Like file new, import the package, and then bam, 35 lines of code from memory, if not knowing the APIs since you wrote them, but that's incredible. Yeah. Well done.
Cool.
I've used them a lot, as you can probably see.
And it's a sound that was created by code. Like it's not playing just an MP4.
No, it's like synthesizing that sound. Yes. So that can be like noise in that sound. Obviously, the oscillator will not have noise. But if you like passing it through like an analyzer afterwards and seeing what values you will actually get, there will be like floating point errors and so on, because underneath it is floating points. So it is synthesized on the spot.
That's really interesting. So I'm curious, in terms of like the spec and how it's implemented, I'm trying to go a little bit deeper now, thinking about like you're a wrapper on top of it, and maybe you don't know this, but in terms of those APIs synthesizing those sounds that we programmatically instruct the browser to play or synthesize, like how exactly does it ensure that they sound the same, through different browser implementations and different, individual client, browser instances?
So I guess a lot of it is a part of the spec. So like it defines that you have to have within this precision and this precision for different parameters and so on. But of course, there is some relaxation for the different implementations. So some implementation might be more precise for different things. But I think a lot of them use the same implementation underneath, which is some implementation in C++.
Okay.
Yeah, so I think a lot of it is common, but obviously some of the browsers might have different opinions or like don't want to be as precise in different options, which could be for different reasons. It could be for performance, for battery life, for not deafening the user.
So if something doesn't work the way you expect, don't blame C# and Blazor. Start with JavaScript and then blame C++. Got it.
Yeah. It's always C++, always. Yeah, so the next thing we wanted to do is actually kind of animate the gain of the gain node so that it eventually silence out and disappears. And for this, we will again await using, and then we'll have an audio param, it's called, and get await gain.get gain async.
You forgot your variable name.
Again, what we'll call this?
I got you. I'm the compiler. I got you.
Yeah, awesome.
This time I noticed.
And yeah, basically, so it just says that this audio param that represents the amount of gain to apply. So now we have like the parameter itself that we can manipulate, and then on the parameter itself, we can change it in different ways. We can set the value as an absolute value just at the current time, which will not sound very great because it will be like an instant stop and will be like a crackling sound in your microphone. We don't like that. So instead, we will use the linear ramp to value, and that just specifies that we want some value at some point. So let's say 0, and then at what time? It needs the time in the time domain of the current audio context. So actually, before we do that, we have to get the current time, which is just a double, and we can get that from the audio context. Actually, there's a lot of places in all kind of different browser APIs where we could get the current time, but obviously, as we're just using the audio context, this is one of the easiest places to get it. It's
Well, you're right. Someone is asking like if it supports Apple Silicon, and so it's not about the architecture so much. It's like more of the browser that you're using, right?
Yeah. So it should support Apple Silicon as like, and I guess you can install Safari or Chrome.
Some very old.
Yeah. As long as you can install the browsers of the different versions that support the API itself, then it should be possible. Yeah.
And there was another question earlier too that we wanted to wait until it was more appropriate to ask, in terms of the demo here. But is there like a way to provision or like, alter the tempo?
It kind of depends on what he means by tempo. So you could think of it as like the frequency, which is just another audio parameter, which we could change throughout these different APIs, like the linear ramp.
Mm-hmm.
Or it could maybe mean like if you're playing like a couple of notes in sequence, like how quick they play. And obviously, if we were going to control this from .NET, we'll just use some timing API, like the timer, to set up how often we want to play some sound.
Got it. Okay.
So that's also one of the nice things about doing it in Blazor is that we can use things like the timer API that we are used to, but still get the capabilities of like playing sound, which is normally native only to the browser.
Yeah, I keep just in my head riffing on what Cecil was recommending before, like having almost like a Blazor app that's got all these different controls with like the different names for like, the oscillator node, and you can tweak it live and then just, start splatting different sounds together and playing them over. And that's really cool.
I actually have a demo for that.
Okay.
Later,
Perfect. All right. I don't want to spoil it. I don't
just describe.
I don't want to spoil anything then. Great.
No, that's good.
Awesome.
That's good.
Awesome.
Yeah. And then we want offset on this time because again, we don't want it to just stop immediately. And we can see here that the time is in the unit seconds. So we'll just say that it needs to wait a half second more before it actually finishes at 0 and stops the time.
I'm
Then
not familiar with by beat.
me
Nor am
neither,
I. Yeah,
disappointingly.
no.
Okay,
Is it some kind of loop?
we're
looper?
gonna have to.
Right. Oh gosh. There
We're
goes my
gonna
entire
have to
afternoon.
research.
And I think it started up again. So let's try to press the button now.
Oh, that's like an
Are you hearing
airplane,
like
like boarding now, or like plane's gonna close.
yeah.
The belt must be what is it? Fasten, whatever, attach.
Oh, the seatbelt, fasten your
Yeah.
seatbelt.
Oh yes.
I was looking for the word and I couldn't see it. Or
No,
say it in French, but
I
you
almost
got it.
said it in Portuguese. It's like,
exactly. That's the thing. I was like, fastened belt, whatever.
We've got you covered here on .net Live, right? Wherever you're watching from.
all languages.
Yeah. Awesome. And then just like the final part of this small demo is just like trying to show that we can play different frequencies and what that means. So I'm just going to add a parameter to this method that defines the frequency, and then say that the oscillator will be instantiated from that frequency. And then let's make this into a lambda, and then say that this specific button will still be played with 440, but then have two other buttons. Then let's call this low, middle, high, and then let's say 550 and 660. I don't think these are actually sounds that sound good, but they are frequencies. So we'll be happy for now.
We did have another question too. While you're pulling that up, we did have several questions actually. One of them was, how precise are the timings? And I was actually thinking about that too, because there is some, minor delays with like the interops, the hops between, going from C# to JavaScript, and just so how do you manage that, I guess, or how precise are the timings?
Yeah. So obviously there is some delay when you do the JS interop itself. So you don't want to rely on that too much. And obviously this will only get worse if you're actually running this on Blazor server instead of Blazor WASM. Because then all these JS interop calls, they will be over the wire, which could be a long time in relative, like obviously not an hour, but it could be longer than you expect. So generally I kind of depend on using these APIs like this, linear RAM to value, and then using the system time from the context to actually time things. But there are times where I've used it in like in big sequences of different sounds where I don't want to sequence all these using parameters. And there I just relied on the timer API, for example, to still say that it's at this time. Then if there is any delay, it will be a consistent delay and not something that offsets it. That's kind of my approach.
I like that. That makes sense.
Yeah.
Let's listen to that demo.
Oh yeah. And then
that's good.
ta-da!
Wow.
Now I can see where you're going with the keyboard. Now that makes sense.
Yeah.
Okay.
So just before the stream, I kind of spoiled a keyboard.
Oh yeah, no one else saw that. Oops, I shouldn't have said that.
No, but it's good because that's what we'll get to now.
David.
Like blame on David.
So actually, I've had the keyboard demo for a long time. Like it was one of the first demos I made, but I recently made some addition to it. So like as a basis, I had this. Like I've had this for like a year. We could play some tune like Mary Had a Little Lamb. Whatever. I will try to continue, but yeah. And the new thing that I made is actually using one of my other projects called the Blazor SVG editor, which I can use to edit different SVGs. I also showed this the last time I was on here quickly. But I always find small places to merge this into other projects, which is always fun. And in this case, I've used it as an envelope editor. And this will probably not make sense to anyone because it's like a very audio engineering term. But basically, it's a way where you can model how the key press will sound with regards to 4 parameters. So there's the attack, which specifies how quickly the sound goes up to the full volume. Then there's the decay, which specifies how quickly it goes down to like the volume that you will be at while you hold the key down. And then after you let go of the key, there is a release, which is this last blue part, which specifies how long it will continue to output sound until it eventually goes to 0. So that's kind of like the visualization of this landscape. And then
and there was this question that is exactly what you're talking about, and I was like, this person probably knows about sound.
Perfect.
And it was before you were explaining this. So I was like, is there a way to control the gain with an envelope, like attack, decay, sustain, and release times?
And I'm assuming it's the same question that Female Sabel was also asking about. It was referring as waveform. I'm assuming that's exactly what we see. Maybe not.
There are some other APIs as a part of the oscillator node. I think we saw that. Now I'll try to not go too much off on a tangent, but there is like a separate type that is called the custom type, where we can supply our own audio waveform. So there is some way to specify, like, I want an audio waveform that is like this weird shape as a duck or whatever. And that might be what he refers to, but it's not a part of the API that I have covered yet, as I've yet to find out how to make extensions of interfaces in the WebIDL specifications.
Interesting.
But anyway, so basically I just wanted to show off, like, as a small thing, that I made some different presets. First we have like a glockenspiel, which will be like bells, I guess, in English. So when we've set this to the glockenspiel, then it will sound kind of like bells being strung with some wooden piece. So you can hear like here. Sound very melodic.
Glockenspiel was the name of that type of.
I want that in our shows, like with transitions. Like, okay.
Yeah. And then like obviously like a piano, very close to what we heard before. I might put up the volume a bit. Yeah.
Awesome.
An organ, which is like the you might have seen like a big piano in the back of a church sometimes.
Yep.
That's an organ. Sounds very stiff and turns off and on very quickly, as we can also see in the shape.
Yeah.
And then a flute, which kind of builds up its tone as you blow into it. So we could imagine that that's like a flute playing different notes. Only an estimation. Obviously, like a real instrument is much more complex than that.
That is so cool. Oh my God, I've got so many ideas now. Like the first thing, well, this is just something just totally riffing here, but like I'm imagining you adding like the ability here for people to share this URL, but in the query string specifying all of that stuff. Like I want it to play X, Y, and Z notes, and I want it to be in this, preset that's a custom preset that they could set up, and then people could just like make entire songs or whatever and just share it with the world.
Yeah,
that'd be really cool.
An API, just like with generate, like you an SVG, you pass a bunch of things after and just generate the full song.
Yeah.
What a mess, though.
In
the URL, I mean, not the code or everything. The code is awesome.
Right. Yeah, the URL would be a mess. It would be But that'd be cool.
Like, would you want to use XML?
No, no.
But it
What
might
I-
be like the easiest one, as it's like really close to like something object oriented.
Yeah.
And this project is also on your repo?
Yeah. So
That's the sample.
when
Yeah,
I
that-
shared the demo page on
Mhm.
the repo itself, it's just going into the demo and then going to the keyboard.
Awesome.
And actually, I think what David just said before is a pretty good segue to one of my other projects, one of my other demos. There's a lot of demos, and basically this is close to what you described previously, with like a playground of different nodes that you just connect together. So we can just place an audio destination, we just place an oscillator, we just
Oh
place
my
a gain node.
God.
And then again, let's not deafen ourselves.
Yeah, should we remove the headset?
This is the coolest thing.
And then we can
It's like
just
the best show ever.
connect these together and even dial the
Whoa.
frequency live. Yeah. That's and obviously
We're in
yeah,
a sci-fi movie now.
it's
Right, right.
I want soundtracks for all my shows now.
and as you said, David, it could be nice if this could be something you could share.
Yeah.
And this is exactly that, as you can just mark all this, clip it, and paste it again. Okay, the demo guards are not with me. Something broke.
Oh no.
But normally it would work with just connecting all the different boxes together again.
Sure. Yeah.
But just encoding it in whatever. So it's a blob of text, and you can pass it through the query string.
Oh yeah,
Yeah,
it has
And
an
that's
error
exactly what
down
David
here.
was talking about.
Yeah.
Oh, that's pretty cool. I get it. Even the UI is smooth.
Mhm.
I really enjoy it. Like,
Yeah.
wow.
I think okay, we can do even more than if you're impressed by that. Let's again construct this.
Now let's do a gain of 300 to blow out our eardrums. We're at a rock concert.
It's like- we were gonna
Preferably
blow up
not.
in social media for the wrong reasons.
And then again, let's tune this a bit down so that's not like playing a weird sound in the back all the time. We also have these analyzers that are part of the API. So we can output some sound to an analyzer, and then we can actually also see the waveform live of the sound.
Oh, look at that.
Yeah. So that's like pretty nice and pretty cool. I think that it's so smooth still.
Can you make the analyzer bigger to visualize that? Oh,
We can
love
just
it.
zoom
Right.
in.
It's SVGs, exactly, right?
Yeah,
that's
it's my editor. Yeah.
yeah. All right. If you weren't impressed before,
Yeah.
you better be now.
And another version of this is one that outputs the frequency, which is actually also a part of the API itself, that it has built-in frequency analysis. So if we were to change this to something that doesn't just have a single note, like a sawtooth, which has a lot of different harmonics and noise, then we will see there are a lot of different frequencies that actually appear in this sound. Obviously, as there aren't any notes that are harmonic with each other. Again, just something I felt was really cool.
It is.
But I think that was the part for that demo, at least. If I'm just going maybe to turn back to my slides.
So now, David, for maybe today or next weekend, you need to build like a looper or something like that, so we could, DJ.
Yeah, with all of my free time, I'll get right on that. I do want to do it though. That would be. I mean, I'm visualizing all of it. It's.
You just need to share this episode to Brady, so at least you will have some help.
Yeah, exactly. There you go.
Yep. Again, I just made a slide in case I forgot the big keyboard. but I did not.
Yeah.
And then the next part, when we have all these classes, there are a lot of places where there are, where eventually, like essentially, you can make a lot of errors because you have to know the API. Sometimes it's easy for me to validate that you, for example, can't place a negative number in this, thereby making it long or something like that. But there are places where we just expect some number, and then you can place something that is out of bounds or something like that. And in those cases, we will get errors. And for that, I've made another library called Blazor.WebIDL, which is made for use made for error handling JS interrupt. So basically, there are a lot of different standard exception types that are defined in the WebIDL specifications. Types like not supported, index not found, stuff like that. And I've just made a wrapper for those types and ensured that we can rather easily invoke different JS interrupt calls with error handling.
So if
And
that's
this would oh, go ahead.
Oh, I'm sorry. I was just going to say, like, I want to emphasize the importance of this real quick to our viewers that may not be aware, but like, if you've ever tried catching an error in JavaScript or even TypeScript for that matter, the type of error that is raised is it's almost impossible. It is extremely frustrating and irritating, and I cannot tell you how many times I've sworn and I've wanted to slam my keyboard and break it. But the fact that you can now do that with a strongly typed, language, C# in Blazor, that is absolutely incredible. Like this is a game changer, and I'm not just saying that because I like Blazor.
My question was gonna be this. This is more generic than just your library wrapper, right? Like it's for other kinds of interrupts with JS.
Yeah, exactly. So I made it as a general purpose library that you use in all other libraries or projects that use JS interrupt to get better error handling. I just also
Awesome.
use it in Blazor.WebAudio, as I saw a lot of places where it would be useful. And I just figured I wanted to show a couple of places.
Yeah, let's do it.
Or at least one place. Actually, first let's check out the if I can find my different. Here it is. Let's first find the WebIDL repository and see what we need to set up in order to actually use the error handling. And I haven't actually defined that in that repository, but I've defined it in the media capture streams repository. I'll have to remember that afterwards.
Homework for you.
Yeah, I was just gonna say more open source work.
Yeah,
it never ends, my friend. It never ends.
So the first part is that we need to call this method when we set up our Blazor application, if it is a Blazor WebAssembly application, and that is the only scenario. And basically, it's something that bootstraps some helper modules, as we can't do that synchronously in Blazor WebAssembly. So we will just paste that over here. So now that part should be done, and actually that just means that this is now using the error handling JS interrupt out of the box, because I've written it to use the error handling. Yeah.
Oh, wow.
So you don't have to actually change your code other than that.
I don't have to, because I wrote all these different methods to specifically use them, as we can also see in like the different comments for the different methods, that it defines that we can throw an invalid access error exception and so on.
Perfect.
In different scenarios. Yeah, and basically I just wanted to show that if we then set using,
That's pretty cool.
and then put around a try catch here. And then we can either catch exceptions specifically from the WebIDL library, or we can catch any exceptions. Let's just catch any for a start. And then we also want to output this somewhere to the user so that they know there happened some error. This is why you didn't hear a sound or something like that. So I'm just going to use a nullable string called error, which obviously isn't how you would do error handling in a real scenario, but
Sure, right.
we will for now.
We are in a demo.
It does make me want
Live
to actually
coding.
have a sound for my errors, like bum bum bum.
Oh no.
Oh, that could be cool. And then we're just going to output the error if it is not null. And here I'm just going to say error is equal to, let's do some formatting. Let's first say the .get type, because this is kind of what the library brings, like actually showing to the user that this is of a specific type, and then also putting out the error message. Let's put that in some asterisk. Whatever. We'll ignore this. And then for now, we haven't really changed that much, so the thing should still work and should not fail. But let's try to intentionally break something. And it could be something like the connect method that we looked at just before. And here we see some different scenarios where it can fail. So one of the scenarios is if the output, which is like each node can have multiple output channels. Most of them only have one, and that is also the case for the oscillator. So we can define some output node, output channel that is outside the bounds of how many channels it has available. And in that case, it will actually fail instead. So once that has built and we press the button, we actually get the error out, and we actually get to know that it's an index size error exception and what the actual message was. And this is different from normal JS interrupt, where you wouldn't get the error type. So you would only be be able to say, okay, some error happened with JS interrupt. I'm never going to find out what, but at least I know that something didn't work, as always.
That's the truth. You're never gonna find out otherwise.
Try an error to find it.
And then like logging this in some system so that you can know for all your JS interrupt calls, what kind of errors you get in what scenarios is obviously very valuable.
Absolutely. Yeah. So then the developer is empowered to know exactly what they need to go fix, right? So they can say, oh, this is exceeding this number of outputs. So I need to go look in the code and find out where that could potentially be the case, So that's awesome.
Yeah.
Well done.
And it can both be like in this case where it was like a programmer mistake, but it could also be that one of the inputs was like a user-defined input, so that okay, I have to sanitize the input or like have to validate the input in this case.
Awesome.
Yeah.
Well done.
Yes. And I think that was pretty much it for me. I don't think we're going to get through the
no, that's okay. That's okay.
The media stream part.
And we are right on time, so it's like we can finish a minute or two early, but it's,
and that's just
perfect timing.
That's a reason to have you back, Kristoffer. See, that's how it works out.
Yeah. And I just wanted to share this as an end, like where are we now? What's going to happen? So first of all, I'm going to finish up Blazor.WebAudio. I'm not done yet. I think actually if I go back to the project and we go to the status page, there's like the small progress bar I talked about in the start. So we are at 71% of the whole specification covered. So I'm only missing 29%. Looking forward to getting done with it. Yeah, just to say that I have finished the whole spec. And then obviously I'm also working on a lot of other projects right now. The Blazor.WebIDL, as we just saw, the Blazor DOM library, Blazor Streams, Blazor Popover, as some have might seen on Twitch and Twitter recently. And then the next thing is the Blazor media stream recording library, which basically enables us to also record these different sounds that we generate. Again, tying into the whole DJ thing. If we are going to make awesome music, why not also record it? And then the last thing is that I will be attending the Copenhagen Developer Festival this year, 26th to 30th, talking about Blazor.WebAudio a bit. So if any of you are there, then hit me up.
I would love to go to Copenhagen.
Would love to.
Absolutely.
Yeah. But
So
if you're in
that
the area,
library
go meet with Kristoffer. Thank you so much. That was awesome.
was awesome. So all of the Blazor Web Audio library, are you accepting contribution? Like, are you doing it by yourself? How, like, since it's open source?
It has primarily been me who has worked on the different projects. And also a couple of them are still experimental. For example, the Blazor Popover library. But some of the ones that have lived longer, for example, the Blazor file system access library, as we saw last time, I've had different contributions to, both in features and demos. And I would be happy to have contributions to the Blazor.Web.Audio library as well. Again, both actual coverage of the spec, adding tests, adding more demos could be cool. So any kind of contributions, or if you find any issue, just file an issue on GitHub as well, would be very appreciated, as that's one of the way that we find out that something doesn't work.
Wonderful. So if anybody is interested, here you have it. So just reach out on any of the social X, Mastodon, and what was the third one? GitHub.
Yeah.
Awesome.
Excellent.
So are we going to say our goodbyes? Is that our goodbyes already?
I think
There's
it's
no more
time.
questions.
Did you want to add anything before we wrap up?
Not really. I can play a tune to my exit.
A little jingle while I'm saying what's coming up next week.
I have something prepared.
Oh my God! So
I don't want to talk over that.
it.
That's filter. Yeah. Is it? No. That's Mario.
It's from the Wii store.
I was looking. I was like, I felt like at the beginning, I felt like it was like a Harry Potter, but I was like, no, that's kind of Mario-ish. But with one finger is hard to play, and like one finger being the mouse.
That should be a touch screen. You should get touch screen and just da 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 like an actual piano.
Yeah.
Oh my God, so many ideas. This has been great. Thank you so much, Kristoffer.
Yeah, thank you.
It was awesome. Thank you, everybody, to watch on dotnet live. Check out for all the good content that we put the link. If you have some idea, if you have projects and you want to come on the show, talk about it, you have all the links that we share in the chat. The links is going on. And next week, I don't have the exact topic, but we'll receive Mabruk. And I'm sure it will be wonderful. I'm just sorry that I don't have right now the topic of this session. But every Monday we'll be here. So come join us. We're live.
Awesome.
Have a good day, everybody.
Thank you. Bye, friends.
Bye.
Bye.